So that would be like the first indication that something was wrong with the AC motor. So yeah, without having the vibration wireless sensor on there, there's quite a big gap there in terms of having time to prepare and respond to the failure in a controlled manner. Usually it's the first time they know there's an issue that the circuit trips.
Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to the latest episode of the Trend Detection Podcast. I'm really pleased to be joined by Emily Trott, one of my favourite customers, I'm going to say. I think I'm allowed to say that, BlueScope Steel. And I say favourite because we've had many people from BlueScope Steel on in the past telling their amazing story of their work with Siemens and Senseye Predictive Maintenance as well. And we've talked about in the past many sort of success cases and asset success cases, with Chris Watson in particular, one that springs to mind. But today, I'm very pleased that Emily's agreed to join us today, and we're going to talk through another amazing asset success at BlueScope. But before we do, I guess I'll pass over to you, Emily, just to introduce yourself and your role at BlueScope.
Hi, Emily Trott here. I work at BlueScope at the plant in Victoria in Australia, and I'm the Asset Intelligence Project Leader there. So I'm leading the project to put all these wireless sensors on equipment and, getting them onboarded into Senseye Predictive software.
Fantastic. So I guess the best place to start is maybe you could provide a bit of background on the success case, what asset type it was, and that kind of thing, just the story behind it first of all, and then we'll sort of dive into the detail.
Yeah, no worries. So the asset in question is a DC bridle motor. So it basically drives a gearbox that drives a roll in the line. And basically the DC motor has a vibration sensor on it, and also it has a AC cooling motor. So the DC motor has an AC cooling blower motor attached to it. And it was actually the AC blower motor that was vibrating and causing the issue. And the sensor on the DC motor picked it up and put a case up in Senseye.
Fantastic. And I guess for the audience's benefit as well. So what role does the cooling blower motor play in the mill itself?
So the blower motor is crucial to the DC motor cooling. So it sits above the DC motor and drives a fan that blows cool air through the motor. So the DC motors don't have like a fan on the end of the shaft like AC motors do. So they need to have a separate kind of cooling system. So it's crucial to keeping the DC motor cool while it's operating. And without it, the motor would overheat and you would get motor failure from insulation breakdown, that kind of thing. So it's very crucial to the operation of that motor.
Yeah, and as it's so crucial, that's going to be my next question. So what is the actual operational impact if it did fail unexpectedly?
So if it would fail unexpectedly, we'd have to shut the line down for a period of time, usually probably about 24 hours, because we have to do a controlled stop on this line to prevent product loss. And so to avoid that impact, we can do like a slow cool down, controlled cool down of the line and pull up and investigate that motor or repair it or remove it and replace it with a spare in a controlled manner, rather than if it just tripped off suddenly and caused the DC motor to overheat.
And I guess think about a world before Senseye as well. So it's great that it spotted this issue early enough for it to be sort of resolved. But prior to Senseye, Emily, how would sort of issues like this been typically detected, and what are the gaps between what happened then and where you are today?
So usually we don't do an awful lot of monitoring on these AC motors, even though they're very crucial to the DC motor operation. All we have is maybe trip detection and alarming. So if that motor trips off, it initiates a line kind of slow down so that the trades can go out and have a look at the motor and either restart it or, investigate what's going on. So that that would be like the first indication that something was wrong with the AC motor. So yeah, we don't, without having the vibration wireless sensor on there, there's quite a big gap there in terms of having time to prepare and respond to the failure in a controlled manner. Usually it's the first time they know there's an issue that the circuit trips. So yeah, there's quite a big gap there.
And I guess when that alert came in from Senseye, and of course I know there's lots of assets onboarded and across lots of sites as well. But what made this particular case sort of stand out compared to other cases that might have appeared?
So initially, it was only a very small increase in vibration. And despite that, Senseye still put a case up. So the people that look at the cases first are our equipment specialists. And they alerted the trades to just go and maybe grease the DC motor because that's where the sensor's located. And they went out there and they greased the motor and didn't really see any change in the vibration, but they closed the case and put the asset on the watch list. And then, so when the vibration increased a little bit further and another case came up, it prompted a little bit further investigation. And firstly, they thought that it might just be the coupling, so the motor to gearbox coupling. So they had a small amount of downtime coming up. So they had a bit of a look at the coupling, but couldn't find anything wrong with it. So the next port of call was to do some vibration analysis on it. So we have a condition monitoring technician and our trades can take vibration data using a data collector that gives us a bit more insight into what's going on with the motor. And we don't traditionally do the DC motors because they're a variable speed motor and it's hard to collect vibration data on variable speed motors. So basically we created a machine in our data collector, went and took some data on the motor and couldn't really see anything that was telling us what was wrong with the DC motor. So we just kept kind of keeping an eye on it and they started planning to replace the DC motor. So then obviously it escalated further and they went out to retake some vibration and the technician noticed a strange noise coming from the blower motor. So we added the blower motor into the data collector and took some vibration measurements on that, and we could clearly see that it had issues with its bearing and it was vibrating really bad. So it basically changed the course of how they were going to address the issue. And instead of replacing the DC motor, they went ahead and got the AC motor removed on the next maintenance outage. And that was when they discovered that the motor had quite substantial bearing damage, the motor and the bearing had seized. So it was only a matter of time before that the motor fan would have failed completely.
Yeah, and that's such an interesting story for me because often you hear about a case was raised and then it's investigated and it's fixed, but from what you were saying, it was like multiple cases raised. You know, there was intervention, then there was a human hearing something was wrong as well, which is obviously equally important as well. So that's a really interesting story of how you came about eventually got to the root of the issue, but it was sort of multiple stages between the Senseye platform and obviously the humans in the loop as well.
Yeah, and it was quite an interesting case, or a success case, because I guess it also gives confidence to the people that are looking at Senseye that these sensors can pick up a wide variety of failure modes. So this wasn't really a failure mode we thought that the vibration sensor would pick up. Just having one sensor on the DC motor could pick up an issue with the AC motor. So yeah, I guess it really gave the team confidence that these sensors can be very useful for not just the equipment they're attached to, but equipment around them as well.
So I guess so. Yeah, 'cause you mentioned two sort of different placements of sort of vibration there. Was that a sort of strategic decision to do that then, from what you're describing, to place it in other places?
Yeah, so I guess initially we mainly deploy to the drive end of the motor, just one sensor, and we put one sensor like on the gearbox on the opposite side. And we also, on these bridle rolls, we have a sensor on each of the roll bearings as well. So we try to cover the asset at to pick up failure modes like coupling misalignment or coupling wear, bearing wear. So if we've got a pump, we put them on the pump bearings to pick up bearing failures, but also unbalance in fan impellers or pump impellers. So yeah, it was a strategic approach to just put one sensor on the motor itself.
Absolutely. Very interesting. And I mean, we talked about this before. I know with sort of asset success cases, usually there's a sort of return on investment or a figure attached to it. In this case, it's sort of around 24 hours of unplanned downtime. It's obviously very significant. But in terms, from your point of view, Emily, how is this sort of value understood and communicated internally as well?
So we put together success cases for these types of events, or if there's a substantial avoided downtime, or if we've saved a lot in repairs, we've been able to get it out before it's completely failed. So we make a substantial impact that way. Or even if it's just like a really interesting failure mode pickup. So we create these success cases and they get presented at a management meeting. And I also send them around to all the maintenance managers on site. And then this time around, we've actually got a newsletter that gets communicated to every person on site once a month. So we put a little bit of a write-up about it in the newsletter just to kind of get the message out there to everyone. So yeah, going forward, we'll be highlighting these success cases in the monthly newsletter for site, which is great because then it gets people thinking about the sensors that they're seeing when they're walking around, and also maybe where they could benefit on other pieces of equipment that they're working with. So yeah, it's good.
No, that's fantastic. And from what I've seen from the Siemens point of view, there's plenty of success cases coming in to fuel your newsletter as well, which is
yes,
which is great. Which is great. But and of course that's important. I mean, have you any stories of where sharing success cases like this has inspired sort of a new approach from colleagues or a new way to apply Senseye? Yeah, I'm just thinking, is there any stories that followed on from being in? Because I'm sure with these numbers and the success and how impressive they are, it must have inspired some next steps for certain people.
Yeah, definitely. So we have a bit of a forum with BlueScope where we collaborate monthly or get together monthly with the people in our American BlueScope, our New Zealand BlueScope, and also Port Kembla. So I talk a fair bit with Chris Watson, who you mentioned before. So yeah, we all talk about where we're using the sensors, if we've got anywhere new that we're trialing. So we do a lot with temperature monitoring. So we're always keen to learn what we're monitoring with temperature, whether that's, I think Chris is doing a trial with monitoring accumulator, like hydraulic accumulators with temperature to kind of pick up some faults there with the internal bladders. And we've got some crane wheel temperature monitoring and crane wheel greasing. So yeah, we do try to share our ideas, and I guess that was the reason behind creating these success case slides in the beginning, was around trying to share it across the business and being able to show your use cases and then sharing that with other sites. I know some of my projects, BlueScope Thailand have picked up for their deployments. So yeah, that's just kind of how we do it.
No, I mean, it's really inspiring. I think that's the word for it, because I speak to lots of customers and stuff, but I haven't had this sort of level of sort of knowledge sharing and community. And you had I don't know if it's still the case, but you had a Senseye school. It might have not been called that, but as well, which is another sort of layer to it as well. And I guess it's only helped the adoption and the rollout of Senseye, in Australia and beyond, let's say.
Yeah, we do have a Senseye school. So Chris Watson and I kind of run that. So I run it for my site down in Victoria, and then he's up in New South Wales. So He runs it up there, and we're always trying to collaborate even on how we train people in Senseye. And a lot of our training is around the case management and being able to give good information into the case feedback to provide that AI insight into that, what's happening, just to kind of enrich that. And there's some really good, features that are coming out. So we're always sharing that amongst our users and promoting that with them. So yeah, it just creates that. I guess we're like a bit of a Senseye community. So yeah, it really does, I guess. Yeah, it just gets us all talking together, and we're all trying to get the best that we can out of the system. So yeah, really good.
No, fantastic. No, I mean, it's really fantastic to hear this from my point of view. What I wanted to do, actually, and I think maybe wanted to ask this question a bit earlier, but when you describe sort of the process for identifying what was wrong and fixing it and stuff, multiple sort of layers and multiple people involved. So I just wanted, I think it's of interest to people whether they're customers of Siemens or not, but sort of your process when a case is raised, like a typical what would happen. I know it depends. It's a case by case basis, literally, I guess. But maybe we could talk about how that works in reality, and how do you bring different people, condition monitoring experts and maintenance people and tradies, as you mentioned as well. I mean, maybe if people outside of Australia might need an explanation about what a tradie is as well. But,
okay.
Maybe I don't know. Maybe they know, but it might be useful to understand your process, because it'll obviously be unique to BlueScope.
Yeah, so I guess when we rolled Senseye out, we kind of had a look at who would be the case triages and who would be the ones that would kind of review them and then, organise the follow-up. So in our business, we have what we call equipment specialists or reliability technicians, and their primary role is to, oversee the equipment reliability. So it kind of fit with their role to be the kind of first responders to cases. So we spent a fair bit of time with that group and took them through case training. And with the case training, it was all about having a look at the case itself and having a look at the trend history for that piece of equipment. Was the piece of equipment, was it a process related change? Is that why the vibration's gone up? We predominantly use vibration sensors on site. So a lot of it's around, interpreting what the vibration data is trying to tell us. And some bits of equipment, if they're variable speed, will vibrate at low speed sometimes or at high speed. So it's just about interpreting the data. And then I guess if it is a vibration related case, then they ask, like in each department, that we've got people that can take vibration readings with the data collector I mentioned before. So they will go and have a conversation with those trades, usually mechanical, and they will take the in-depth readings, and then we'll have a look and see if we can determine the cause. Some of the cases when it's just temperature related, or even if it's just acceleration, so if we have a high acceleration in the vibration, it can just mean that the bearing needs some grease. So they will directly ask the mechanical trades to go and do a bit of inspection of the equipment and put some grease in to see if that will fix the problem first up. So yeah, I guess we've had these sensors installed for a few years now. So we've been able to monitor and kind of, if we put some grease in, we'll see the vibration reduce. So we know that that's a good way to combat that. So they kind of over time just learn these little tricks to kind of, fix the equipment or do investigation. But yeah, that's kind of the process. And then they'll go back in and put their findings in as a note or a work event and close off the case.
Yeah, and thank you for sort of outlining that. Because again, what's interesting is it's both, like you say, you're closing the case and providing the feedback so the AI learns, but also, as you mentioned, the humans actually make it doing the work, as it were, have also learned something as well, which for next time we can try and put a bit of grease on first of all to see if that solves it. And then if not, and if there's another case raised or if there's a change again, we can then investigate from there. So it's sort of helping both sides of the coin, as it were.
Yeah, and it actually helps them kind of understand vibration too. So my background is I have an electrical trade background, but I also did condition monitoring for many years. So I can basically interpret vibration spectral data. So even though these sensors just give you like an overall vibration, velocity and acceleration measure, and doesn't really tell you exactly what's causing the increase in vibration, you can kind of see patterns. If it's just acceleration going up, it's usually going to be a bearing related issue. So you're going to need some grease in there or something like that. And if it's velocity just trending up, then it'll just be like usually a mechanical issue. So, there could be loose bolts, it could be a coupling, it could be impeller imbalance. So, just giving that information to the people that are first looking at these cases, it actually, I guess, enriches their knowledge of vibration and just condition monitoring, which is really cool.
Oh, fantastic. Really great to hear. As we come towards the end, one thing I did mention, Emily, before, and the reason for it is because it's nice to have a little surprise. So we've actually introduced a lightning round to the conversation. So sort of one word answer. It's almost like the first thing that comes to mind. So we'll go to that in a sec. But before we do, just based on this success, and I guess the sort of the broader success you've described today, what are the next steps for BlueScope in terms of scaling predictive maintenance? I know you've scaled it a lot already, right? But there are more plans in the near to medium term.
Oh, definitely. So there's a big push for scaling at speed. So we're looking at common assets across the business, looking at what's worked, where we've had success cases previously, and then just basically adopting that method and rolling it out across common assets across the business. We're also very focused on how we can use the sensors to reduce routine inspections, and as we've built trust in what the data is telling us, how we can use that predictive maintenance to drive our inspections and maintenance rather than using time-based schedules. So yeah, we're very focused on that side of it at the moment across the business.
No, fantastic. And long may the success continue. I'm almost certain there'll be further call if you guys are open to it, because there's just so many. I've really enjoyed obviously this conversation, but with Chris and with Colin in the past. So yeah, as promised, the lightning round. So nothing too scary, I promise. But so the idea is I'm going to ask a question and then give you 3 answers to choose from. It's just the first thing that comes to mind, right? So so if we go with the first one, so in one word, how would you describe the feeling when a predictive alert actually prevents a failure? So relief, validation, or satisfaction?
Satisfaction.
Excellent. And what's the biggest misconception people still have about predictive maintenance? So complicated, expensive, unnecessary.
Unnecessary.
Awesome. And last but not least, so fix it before it breaks or learn from the failure. Which camp are you in? So prevent, learn, or both?
Both.
Oh, and I'm going to break my own rule here. I'm going to ask why both.
So I guess, I think it's great to be able to fix something before it breaks, but I also think that if you have a failure, there's always something to be learned from it. And sometimes you get richer knowledge by the failure than if you've prevented it, if that makes any sense.
It does. It definitely does. Definitely does. Yeah, no, because you would never, you'd never want something to fail, right? For the reasons we talked about in detail today. But yeah, there's always something to be learned from that. Either way, how to interpret Senseye, for example, or when to react, or we talked about greasing, things like that first and stuff, so there's lots to be learned from that. So I completely get where you're coming from there.
Yeah. Even a Senseye failure is still a success because there's always something to learn, even if it's understanding what Senseye was telling you so you can prevent it in the future. It's just great. It's just knowledge.
Exactly. That's a really good attitude and really positive note to end as well. So I'd like to, thank you again, Emily, for joining us today and taking us through this fantastic success. And I'm sure we'll see many more in the future as well. And I'd like to thank everyone out there for listening to the podcast, and we'll see you on the next episode. Thank you very much.
Thank you.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.